What's up, heathens? How y'all doing? Today we're taking another look at the Nathan Thompson discussion where Nathan actually tries to use Lake Pontchartrain and the pylons and the pictures that Soundly took as proof of a flat earth. If you want to know how he does this and how he fails, then please stay tuned.
And you don't think you'd be able to see a curve on a lake. So every globe head who's
not
ever
horizontally, which is what D. Marble was hoping to prove.
Every globe earther who's ever used Lake Pontchartrain, go watch John's video. He says you can't see curvature on lakes, so nobody can use that video or that meme.
No, I mean, there's Soundly's pictures of Lake Pontchartrain that obviously prove that you can see curvature. I mean, it's not curvature like horizontally, obviously,
Wait,
but
Don,
it's
that obvious.
Huh?
Curvature? Is that what you're saying?
Sorry, I lost you for a second. What did you say?
Are you saying Lake Pontchartrain shows you can obviously see curvature?
Well, I mean, yeah, with the
total distance of those power lines is 15.9 miles. But per Soundly, the viewer height was 35 to 50 feet. So like, let's say 40 feet. The distance between each pylon is 0.18 miles. So you got 40 pylons in Soundly's shot, which is, it's only 7 miles. And you're saying we can see significant curvature, significant curvature over 7 miles of Earth's surface, John?
Yes.
That's your claim, is that we're seeing 7 miles of curvature over Lake Pontchartrain.
You very obviously see the pylons changing with the curvature. So yes.
So over 7 miles, we can see distinct curvature, even though you can't even see 1 degree of Earth's curvature at 68 miles. Is that your argument, John?
Wait, can you repeat that, please?
Yeah, you're saying we can see visible curvature at 7 miles on Earth's surface, but at 10 times the distance, this is funny to say, we're only seeing 1 degree of Earth's curvature at 10 times that distance, and every globe head will tell you we can't see any curvature.
So, Nathan, do you know, are you familiar with the equivocation fallacy?
I'm not super familiar with that one, but go ahead if you want to educate me. I'm open. You've taught me a couple things today already.
All right. So, equivocation.
Yeah, where a false equivocation fallacy, where you compare two things that aren't related. It's like a false,
kind of similar. I mean, that's a false equivalence, not a false equivocation. An equivocation fallacy is where you basically take one word or subject and you use it in two different ways as if to conflate the conversation being had to make your point. And that's kind of what you're doing right here, because when I talk about Lake Pontchartrain and how we can see curvature using the pylons and Soundly's images and everything like that, I'm talking about like in the distance, like that's one axis, right? And then the other axis, the horizontal, hold on. The horizontal axis, we wouldn't be able to detect curvature at that point because of how close we are to the Earth. We wouldn't be able to visually detect it.
Okay, so in the first 7 miles of the picture, or sorry, I've been to Lake Pontchartrain. None of that is an extremely zoomed in photo. Can we agree?
I don't know much about the photo as far as like how much it's zoomed in or anything like that. Like, I mean, I don't know details about that, but
okay, well, it's fully zoomed in because he didn't start seeing. You can't see half the pylons. It's got 80 pylons, and there's only 40 in the picture. So
okay. So
what's happening there is it's compression towards the horizon. That's why you don't see any curvature as you leave. Wait, hold on. There is no linear curvature geometrically as the pylons are leaving you. That's why Soundly zooms in on the very last part, and everyone nitpicks and cherry picks that one picture. But there's no visible curvature over 7 miles. We can go to any lake and look at a 7 mile lake and see there's no curvature on 7 miles. We can measure it with a laser, John. We've been doing laser tests. What do you know about the Gaussian scale?
The Gaussian scale? I have not heard about it. I would love for you to educate me on it.
Okay, yeah. So the way lasers work is they're emitted on a bell curve, and so it's most intense in the center. It's called the central intense axis, and then the light gets less intense as you move outward from the central intense axis at a gradient that's exponential or logarithmic.
Okay. So none of this actually proves that the pylons are just getting smaller. I mean, do they get smaller? Yes, because of perspective, but you can't explain why they disappear from bottom top. And it's not like they disappear gradually. They disappear like immediately. Like as soon as the Earth's curve hides it, it is gone. And you can't explain that with perspective.
John, it's because it's refraction. It's being compressed towards do you admit that the atmosphere, you seem like an expert on light, it causes things to happen to light?
Well, yes, it does, but I don't see how refraction causes it to compress.
It does. Okay. Well, especially on a hot day, air is most dense at sea level, and then there's a marine layer that's all aqueous and full of salt. And so as the light enters that medium, it bends downward. It gets redirected downward. Okay, so that's why all that light is flattening out towards the horizon, is because it's bending downward, not because the water is bending downward. We can measure the water. We can look at fluid statics and see the surface of every large body of water is flat and horizontal to its container. So
wait, hold on.
More measurably flat. We can see way too far, John. So if the Earth was curving at 7 miles and at a rate at Stanley's photo, we would never be able to do 17-mile laser test 3 feet off the ground.
So wait, hold on. How many pylons exactly were in the Lake Pontchartrain image?
According to the notes, I have 40.
40. Okay, and they're supposed to be how far apart?
They cover a distance of 7 miles.
No. How far apart is each pylon?
I'm not exactly sure, but 7 miles. And
No. I mean, you said earlier exactly how much it was.
I might have misquoted my notes. So what I'm saying now, okay, because I might have misquoted my notes, is 7 miles of what you're seeing is 40 pylons, and the total distance is 16 miles or 15.9 miles if you want to be exact. Okay, now we did a 17-mile laser test 3 feet off the ground, and you're saying that you can see substantial curvature at 7 miles of the Earth. You can see it. You're saying you can see curvature at 7 miles of Earth's surface. But we did it on a 17-mile, which is 2.5 times that distance, 3 feet off the ground. Laser, 3 feet off the ground. Now, you didn't...
Wait, hold on, Nathan. Can I stop you real quick?
Of course.
Okay. So I just have to remark on how hilarious this is, Nathan, because you quoted me exact numbers earlier, and then and that's how you determined that it was 7 miles. And now when I ask you again, you're like, oh, well, I might have screwed that up or something, but it is 7 miles.
It's a total distance of 16 miles, and there's 80 pylons. So go ahead, do the math, dude. I got
No. I mean, honestly, Nathan, I don't know like how many miles that is on the Lake Pontchartrain image right there. And I honestly, I can't trust you because it seems like you just pulled numbers out of your ass and then labeled it as 7 miles. And at 16 miles or 7 miles, it doesn't really matter. We would be able to see curvature, and I've actually got the image up right now. We're looking at it, and you can see curvature. You see the refraction too.
Where?
But you see curvature.
You got Stanley's photo?
Yes.
You're not looking at curvature. You're looking at refraction.
There is refraction in it, but you also see curvature.
And we can see...
refraction does not explain the very top of the pylons that obviously has a curve to it.
Okay, John, are you listening to what I'm saying? The entire distance of those is 16 miles. Check the math. We've done a laser test at 17 miles, 3 feet off the ground. Okay? Now, according to the way lasers work, that light would have to be bending over 140 feet of Earth's curvature. That's your math. That's Metabunk's curve calculator. Not my math. That's your math. Okay? Now, if that were true, beam divergence of a laser beam, you can measure it, and it comes out to, on that laser, which was a 10,000 megawatt, 520 nanometer green laser, the 303 model, it's a 10,000 megawatt, beam divergence is 1.5 mrads, and the beam diameter is 2 millimeters. So, at a distance of 22.95 meters, that's a beam radius of 11.48 meters. Now, at that distance, according to the rate, at at which the light is scattered. And again, it works on a bell curve. So from the central axis, it's getting exponentially. Let me see if I can find, yep, I got it right here. So the Gaussian distribution is a bell-shaped curve. That means that the laser beams are brightest in the center and the intensity falls off towards the edges. Now also, John, they get less bright as they get away from the laser. So at 10 miles, based on the beam divergence for that laser, you're looking at, I think it's 131,696 times less intense at the center of the laser beam at 9.5 miles. So if these laser tests are being observed from 10 miles or 17 miles, that means that the beam divergence at the intensity of the central beam axis at that point is 0.0002417 megawatts per millimeter squared, which is not visible to the eye. That's why if you held up a piece of paper at 10 miles with that laser pointing at it, you would not see the laser on the piece of paper. And we agree that
right, because the beam divergence is too great. But did you say a 10,000 megawatt
piece of paper
laser?
10,000 megawatts.
Okay. So I sent you an image, Nathan, in the chat. I don't know if you can open it up from our chat in the Hangout. But I sent you an image that is a Soundly image where he's got, I'm guessing, a drone and it's going up and down. It's a GIF. I'm wondering, I mean, can you explain that?
Yeah, of course. So the more closer you get to the horizon, I did a drone test like this at Lake Michigan when we could see the entire freaking skyline from the other side of Lake Michigan. So yeah, I did the same test. I have that same video on my, same exact thing. I did it. I have it on my camera. So what that is everyone is inside of an atmospheric dome. So
God, not the Jeranism thing. Come on, dude. Have more intellectual honesty than that.
This works on both models. This is not a flat Earth thing, Godless engineer. This is a reality thing. So the lower
it's not a reality thing. Flat, your personal domes are not a reality.
This is why the lower you are, the more dense the air around you is at sea level. And so if you watch my video and Denver, when I take a moon lapse, vanishing off in the distance into a little dot, that's because I changed my atmospheric dome around me, and the density at sea level is way denser than 10,000 feet above the air in Denver. So there's no glare from the moon. It doesn't even get bigger at the horizon. That's what glare is causing lights to get bigger. It vanishes into a tiny little dot. And we have tons of videos of the sun doing this too. Now, if they're not just lights in the firmament and they're 240,000 miles away.
Wait, you're saying the moon turns into a tiny dot?
Yeah, you haven't seen my video where the moon turns into a little dot?
No, because that is not anything that ever happens. Oh, man, that was a great discussion with Nathan here. I mean, he's totally lost on everything, but it was a great discussion. If you will, please go down below and leave me a comment with what you thought about Nathan and his arguments. Were they just as dumb as I thought they were, or did he have some actual points? While you're down there, make sure you smash that like button and subscribe if you like this kind of content. Don't forget to stand up and use your voice, and I will see you heathens later.